Hold it there. Perfect.
Engineers
Check
spent
the
nearly
angle.
5 years
It's solid.
preparing for a moment that lasted only minutes. If they got it wrong, a billion-dollar
slowly
bridge
down.
could miss its
Hold
target
it.
by just a few centimeters.
Back left a bit.
That doesn't
Stop.
sound like
Easy.
much. It was
Set it.
everything. Because this bridge wasn't built from one side. It was built from 2 different countries at the same time. And somehow, those 2 halves had to meet almost perfectly over one of North America's busiest shipping routes. But here's the question. Why didn't engineers simply adjust the bridge later if something was off? The answer begins with one decision that changed the entire project. Most bridges crossing a river place supports in the water. This one couldn't. The Detroit River is one of the busiest commercial waterways on the continent. Blocking that navigation channel simply wasn't an option. So instead of several shorter spans, engineers had to stretch one enormous span across the river without a single support beneath it. It sounds like an elegant solution. In reality, it created a much bigger problem. The longer the span, the more unpredictable the bridge became while it was still under construction. Every new deck segment changed the forces inside the structure. Every lift changed the balance. Every day, the unfinished bridge behaved differently than it had the day before. Engineers weren't just building a bridge. They were building a structure that kept changing as they built it. And just when they thought they understood how it behaved, they discovered something they couldn't control. Something that could move thousands of tons of steel without touching the bridge at all.
Ensure the surface moisture is consistent before laying the blankets.
Roger that. Applying water now.
Sensor reading is 2.4 MPa. Finish looks good.
That invisible force wasn't hidden inside the bridge. It was all around it. Temperature. Steel expands when it gets hotter. It contracts when it gets colder. On an ordinary structure, that movement is barely noticeable. On a bridge this size, it can shift massive steel sections by several centimeters, enough to turn a perfect connection into a costly mistake. Suddenly, engineers had a new problem. It wasn't enough to know where the bridge was. They had to know where it would be.
Okay,
Hours
lower
before
slowly.
every
Hold.
major lift,
Looks good on the east
engineers
side.
calculated how
Check
the
the west.
structure would respond to changing
Verified. Let's lock
temperatures,
it in.
wind, and its own growing weight. Then they checked those predictions against reality. Again, and again, and again. Survey crews worked with GPS, laser instruments, and high-precision total stations, constantly measuring the position of every critical component. Not because they expected failure, because discovering an error at the final connection
Set
would already
rotation.
be too
Hold
late.
tension on the lines.
Every
Adjust starboard
measurement
tack.
answered one
Slow
question,
rise.
but
Check
it
the
raised
alignment.
another.
Hold.
What if the next deck segment changed everything? As construction advanced from both countries, the remaining gap grew smaller.
All right,
The
tension
room
the
for
cable.
correction disappeared.
Tensioning cable 3.
By now,
Confirming
every cable
95%
tension
load.
mattered.
Lock
Every
it in.
lift
We're ready for the
mattered.
fasteners.
Every millimeter mattered. The bridge was no longer being assembled. It was being fine-tuned. And after years of calculations, measurements, and adjustments, everything finally came down to the moment engineers had been preparing for from the very beginning. The final fit.
Line 1 clear, dropping in. Looks good. Initiate strand pull now. Tension stable. Final lock engaging. Hand tightening initiated. Segment secure.
Keep tension consistent. 2 millimeters left on channel 5. Stop. Perfect. Hold the line steady. Take it in. Watch that swing. Slow. Slow. All right, it's aligning. Secure. Okay, lift team, engage the slings. Signal man, check the tension. Tension steady, ready for connection. Set it down slowly. Verified, it's perfectly aligned.
After
Start
years of
tightening those
planning,
bolts.
the final connection wasn't about luck. It was about proving that every calculation had been right. By the time the two bridge decks approached each other, there was almost no room for improvisation. Every previous decision had already locked the outcome into place. The foundations, the towers, the cables, the surveys, the temperature models. Everything had been leading to this one moment. When the final deck sections were aligned, engineers weren't trying to force the bridge into position. They were confirming that thousands of earlier decisions had brought it there naturally. That's what separates world-class engineering from simply building something big. The most important work happened long before the final lift. Because if you're still making major corrections at the end, you've already lost. When the connection was completed, there were no dramatic celebrations. No last-second rescue.
Secure the bracket.
No
Tightening
miracle.
now.
Just years of precision quietly
Signal is
coming
strong
together
with the last
exactly as
one.
planned.
Next cable.
And that's why millions of people who
Main
will
breaker
eventually
engaged.
cross the Gordie Howe
Verify
International
circuit
Bridge
one.
may
One
never
top.
realize what really made it extraordinary.
Initiating sequence.
It isn't the
Towers.
height of its towers, or the length of its span. It's the fact that two massive structures, built from opposite sides of an international border, arrived at almost exactly the same place, at almost exactly the same time. That was never an accident.
The readings are
It was
stable,
engineered.
within spec.
This wasn't just a billion-dollar bridge. It was a billion-dollar precision
Let's move to the next
test.
joint.
5 years of planning, thousands of calculations, countless measurements, for one final fit. One shot. If you enjoyed discovering the hidden engineering behind the world's biggest megaprojects, subscribe for more stories where the hardest challenge isn't building something enormous. It's making the impossible look effortless.
All right, load it up. Check clear. Watch that clearance. We're almost done here.